having some minor iPad issues today, which normally it's my laptop. Okay. So now should be, okay, this should be the review that was posted, right? Yeah, okay.
Oh, yes.
Yeah, looks like it, right? Okay, good. Okay. So this is the review I want to go over today. I am going to also do those extra homework problems. I'll have to like pull up. Oops, I didn't prepare an extra document for it, but I think I can just write it. And then let me check to make sure one more thing. So I think for the exam, the only formulas that you really need are the log properties you need to know, but like the compound interest and compound interest formulas, and then you like that will be given to you, but you do need to know, I think, the work or something that we had done last time, which we'll do an example of it. So let me figure out how to get here. I want to just make sure. Oh, geez, yeah, they're gonna have to go in their crate. All right, give me a moment to put them in their crate, and I'll get started when I come back. Okay, so we're back in action. Let's see where. Make sure. Okay. Turn the pen on. All right, so we'll get started just by doing this, right? Completing this assignment. Oh, let me pull the chat up. Make sure I'm with you all. Okay. And then I wanted to do some of those homework problems from 8.4 and 8.5. And someone did come to office hours, and I did find out there was like some of the homework problems maybe had, if you've gotten to it, they had like this other projection formula being used that we didn't do, I think, in class. This will not be on the test, obviously, since we didn't do it, but it is covered in the textbook. And if you can't make sense of it, I mean, feel free to like send me a note. But if you click the, like what I did with this, or what we did, right, with the student, if you click the exam, like view example, it does basically the same example with just like different angle and different force and different numbers. And it does, you can actually follow that almost identically with your numbers, right? So if you do get to that and you're like, this is the problem she was talking about, that's what you can do, or send me a note and I can try to explain it, like via email or something like that. Okay. So for number one here, we're going back. It feels like we did this forever ago, but maybe that's just me, to our law of sines and cosines, right? So they want us to give only the angles to the nearest degree because they give us, in this case, 3 sides. So on your test, just be prepared. Maybe it gives you 2 like angle side, or maybe it gives you, be prepared for all the scenarios that we went over. Not probably the hardest one though, whichever, that one that has like 2 cases, that's not going to be on your test, right? So just be prepared for those other kind of simple cases. But in this case, we have 3 sides. So I'm just going to draw my picture, even though it's not going to be to scale. But let's pretend this will be little c, because that looks like the longest side, and that was 55. And then let's say this one is 28, which will be little a. And B is 30. Okay. And so here's our triangle again, not to scale, but just for me to see like, what are we doing here, right? So you basically have to pick, and in this case, we're going to use law of cosines because we're given 3 sides, right? So again, practice and be prepared in case, I think angle side angle or side angle side angle, I think is the one where you use law of sines, or maybe it was side angle or something. The others that use sine, just make sure you know how to do that as well. But we do end up using, like, this is probably, actually, it might be this one on the test, I don't remember, but using law of cosines first, you always end up using law of sines as well, right? So it kind of does both, which is maybe something that would be tested, right? Okay, so law of cosines, I'll just write it up here real quick. Law of cosines is something like c squared. And again, it doesn't have to be c, it could be a or b, but c squared equals a squared plus b squared minus 2ab cosine of big C, of the angle C, right? So we're going to start by doing this. And again, you could plug in, like, you could switch this out and have it be b squared, and this would be a and c, and a and c, and then this would be big B, right? So you can change these, but this is just kind of the general way that we write it, with C first. So I'm going to do exactly that. I'm going to say, okay, I'm going to substitute in all my values here, 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 and here, right? So that I can solve for my one of the angles, and then I'll use law of sines to solve for the other, and then I'll subtract from 180 to get the last one. So let's see. So we have 55 squared equals 28 squared plus 30 squared minus 2 times 28 times 30 times cosine of big C. And so I can solve for this, right? And I can just say, okay, I'm not going to write they're big numbers, right? So I'm just going to write it like this. So I'm subtracting 28 squared and 30 squared from this side, and it just equals negative, well, I will write this out, negative, I think it's like 1,680 cosine C. And then what I do is I just divide both sides by negative 1,680. Right? And then I get cosine of capital C is equal to roughly, okay, so this is roughly what points, it was like, I tried to keep a few decimal places, but they want you to round to the nearest degree. So at the end, we just round it, right? But let's see, I think it was like 0.798 something. And so from here, we take the inverse cosine of both sides, right? So it cancels over here. And then I get that angle C is approximately, again, oh, and this is negative. I think this was supposed to be negative, right? Yeah, I think the sign was negative, yeah. So yeah, it was negative. Okay, cool. So it was approximately 142.9 something, right, and more. But we're gonna round that up to 143, right? So we could fill that in right away, 143 degrees. Then we use our law of sines, and okay, there's not much room here, but law of sines is going to be like little a over sine big A equals little b over sine big B equals like little c over sine of big C. So this is what we can use. And we have angle C. So maybe I'm just going to say, okay, maybe I do this equal to this, or you could just do B and get angle B first. Again, it really doesn't matter. Jakob's asking, do you need to write all the steps in the test? So on the test, you don't need to write something like this. Like, you don't need to write that unless it helps you. And in terms of these steps, you don't, as long as you you do not. So the answer is no, you don't need to write every step, right? But I want you to write at least like the formula or how you start, and then do some calculation, and maybe you end up at this step or something, and then maybe you end up at the answer or something like that. Like, have at least 1 to 2 steps. You don't need to have, 3 or 4 like I do. And sorry, there's another question. Intermediate estimations in this case are all right. Oh yeah. On the test, will we be told whether to round? Yeah. So in this case, rounding intermediate is fine, right? Because we're, that's kind of how this is going. So I will, and on the test, I don't think It'll have similar directions to this, but I don't think if it doesn't specify or something and you round, like it's not going to be like Alex, right? Where that says you're wrong. Like if I, in this case, if somebody did something different and they got 142 here instead of 143 because they, got half a decimal lower, I'm not going to take points off. So I'll take answers all in that. Yeah. And hopefully, Jakob, that answered your question as well. Okay. So law of sines. So I just did little a first, just because I did. So I did like 28 over sine of capital A has to equal 55, which is C, over sine of capital C, which I'm going to just say 143 degrees. Now, again, like if it doesn't matter, but if you said, like, actually, I think when I did this, I might have done 142.9 just in this calculation. But if you use 143, it doesn't matter, right? And so then we kind of cross multiply here and we get 28 sine of 143 degrees is going to equal 55 sine of A. And so then we just divide both sides. I'm sorry, I'm writing over this by 55. And we get, so again, like if you didn't want to write that division step, you don't need to, but sine of A is going to be approximately equal to like 0.307 or something. So again, if you round this early, you might get a slightly different answer. And when I put this, like I'm writing this out now, but when I did do this in my calculator, I might have just done everything all together. So even though I rounded here, my answer may be not totally rounded, right? So alternative cosine side by side formula is less complex. Okay, yes. So again, if you have another way to do this and you get the same answers, that's fine, right? Just please do show work if that's the case. But yeah, this is kind of the traditional way of doing it. And so we would take inverse sine here, right? 0.307. And that's going to be our A, which is about, it was like 17.9 I got. So I would say 18 degrees, right? Oh, and maybe I'll keep this. Okay, now to get B, I'm just going to do 180 minus 143 minus 18. And that should be 19 degrees. And so now these should be all of my angles. And yes, if there's something else, like Jakob said, he has the alternative cosine formula. If you're using a different formula or something that they're all related, right? So if you are using something, as long as you are showing that work and you get something very close to these, like again, if you get 142, 18 and 19, like, or whatever it is, 20 and 19, this is okay. Because that's just like a rounding error, right? Or not even error, it's just a rounding. So yeah. Okay. So that's an example with law of sines and law of cosines. Just be prepared for one or the other. I can't guarantee, that it's going to be the one you like, or maybe it'll be both, but yeah. Okay. So number 2 is saying solve the equation, give exact values only. So in this case, I'm going to rewrite this first one. I would think of when I see e to the 2x, I think of this as e to the x squared minus e to the x plus 6 equals 0, right? Because now I see this is nearly, it really is the same as if I had x here and x here, like x squared minus x plus 6. That's how you can think of it. So if you're still like a little confused, feel free to write off to the side, like x squared minus x plus 6, because this is what we're factoring. But instead of writing x, we are writing e to the x. But it is the same thing. So if I was to factor this, I know it would be like x minus 3 and x plus, oh no, just kidding. Ooh, it wouldn't be. What would this be? It would be x. Oh no, I think I made a mistake here. Okay, let's.
Could the signs be flipped? Because this one results in like imaginary.
So this doesn't factor nicely, but I wanted it to. So this is definitely a typo. And you know what? It might be because I tried to I tried to make this similar to a test question, and maybe I changed signs and really they shouldn't have been changed. So let's pretend this is minus. And I know that I had a note somewhere in my papers that there was a typo, and here it probably is. Now we could keep them both minus. So this would be, Jakob, what you're saying, this would be false if it was plus. It would not work out, right? There's no solutions. But if we change this to minus, just the second part, then if we do that, then we can solve. So let's just do that so that we have a problem to solve, right? But Jakob, you're totally correct.
On the exam, is it more like, is it
going
to be factorable?
You're going to be able to factor. Yes. Yes.
Okay.
And that's, well, and I did check that, but I did not check the review, obviously. So, and it's funny, even in my notes, I wrote plus. Yeah, you still find something, but it doesn't work, right, Jakob? So that's okay. Of course you can find something because it's a quadratic formula. You can use the quadratic formula. But if you can't solve it with, like, if it doesn't exist with E or something like this, then that's one thing. But can
you take the log of an imaginary number?
Well, and exactly, no, I mean, no, I'm sure maybe in some imaginary case you could, but no, because it involves a negative. Yeah. So, okay. So let's see, let's pretend this is a minus and start this again. And even in my notes, it's hilarious. In my notes, I put plus all the way, but I factored it as if it could factor. So clearly I was, a little bit off. So this would factor to be x minus 3 and x plus 2, right? So if we do that, it would be like e to the x minus 3 and e to the x plus 2 equals 0, right? But then you would get this. You'd get e to the x minus 3 equals 0 and e to the x plus 2 equals 0. So you'd get e to the x equals 3, which we could solve for that. But then you get e to the x equals negative 2, right? And so, and Jakob, x doesn't equal 3 because, well, x equals 3, sure, in the green, right? But remember, we have to solve it like this, right? So hopefully that makes sense. So in this case, this here is not possible. And it's not possible because, well, one, you could think of it in terms of natural log. You can't take the natural log of a negative number if you did this to both sides, or the log, right? But e to anything, that exponential, it's never negative. You can never get a negative number when you say e to the 10th, e to the negative 5th, e to the 0.2. You'll never get a negative number. So this is just not possible. But e to the x equals 3 is possible. And to do that, we would just take ln of both sides, right? This x can come in front. So I'd get x ln e, which is just 1, is ln of 3, right? So my answer, my actual solutions for solving is x equals ln 3.
Yeah, that's better.
Yeah, that looks much nicer, right? So I'm sorry if you tried to do this already. For those of you that did, and you were like, what the heck? Quadratic formula with exponential? Like, no fun. But hopefully, you moved past it and you were like, I'll just wait. All right. Now, the next one is a little different because I see a lot of things. I see a number, then I see a log, then I see a log on the other side. What I want is all the logs to be on the same side and the number to be on the other side so that we can use the properties to combine and then rewrite it. So I basically want to say, I could just add log base 7 of w minus 5 to both sides. And then I'd get 6 equals log base 7 of w plus log base 7 of w plus 5. And this actually, based on the properties, right, this is plus is addition, so w times w plus 5. And let's hope I did. Oh, this one is a mess. Okay, so I didn't do a good job on this one either, but I will double check that it's not like this on the test because I thought I checked this earlier, but I think I looked at the test and not the review. But this one is crazy because it's Yeah, right.
It's still doable, but
of
it's
course.
a little
And we're gonna
out
do,
there.
and we're gonna do it. But it's just cruel if this was how your test was. And I like to think I didn't do that, but you never know. If I was mad at the painters who were here doing a bad job, you never know. Okay. So this is 7 to the 6th equals W times W plus 5, or W squared plus 5W, right? So this is crazy because this is, if I subtract, so if I subtract this number from both sides, right, of this equation, we get this gross quadratic formula of W squared plus 5W minus 7 to the 6th, which is 117649, huge number, equals 0. So this does not factor nicely. And maybe I did do this because it factors nicely on your test and then it was nice. And yeah, Jakob, if you kept 7 to the 6th, that's also perfectly fine, because that makes more sense probably. So then what I did is just the quadratic formula. So -5.
It's W minus 5.
W. It is. Oh my God, I changed it. Oh wow.
Yeah, it's okay, but yeah.
I was like, wait, did I? Okay, so
then it gets really bad if you do.
Okay, I was like, did I read it? What is happening? Okay, so these should just be mines. That's fine. Oops.
But anyway, yeah.
Yeah, thank you for that. But not, at least the problem is still, well, either way, it would have been. Okay, so then this means I just have +5 here. Because -b plus or minus the square root of b squared minus 4 times 1 times -7 squared, or 7 to the 6th, right? All divided by 2 times 1. And so after some work with this, I had left this as 5 plus or minus the square root of like a really big number. I didn't get or did I get the decimal? No, it says, okay, so it says exact, which is why I didn't get the decimal, which is why this is cruel. Because if you did have to do this on the test, it would be maybe it's not cruel. You would just leave it like this, right? So your answer here is actually just W 5 plus or minus. Oh, but it's probably not the -1, right? You'd have to, okay, so you would have to check, which you would have to check that. So notice not the -1. And I'm assuming, okay, square root of this, I know it's bigger than 5, right? So this is going to be negative, not the negative answer. But the positive answer should work just fine. So you can just say this, 5 plus this crazy square root. And even if you left it as like 5 squared minus 4 times 7 to the 6th, I don't think I would have been mad about that. But as long as you're writing that work clearly and showing me, and yeah, so thank you. So it's the decimals are 345.5 and -340. So clearly with logs, so the reason negative doesn't work is because this is in the equation, log base 7 of W. And if W is a negative number, we cannot take the log of that. Right. So that's the reason that we're doing this. And so that -340 does not work. And the +1 is going to be good. Okay. Now just because I'm a little bit freaked out, I'm going to just quickly try to.
It's pretty smooth sailing after that.
Yeah. Right. We just messed up at the beginning, No, I'm just kidding. I just want to look at your test real quick and make sure, or at least one of the questions, to make sure that, it's much easier numbers. And does this factor? Yeah. Okay. So yeah, it's already, I had to look at it, but the numbers should be good. It should factor nice. Now that makes me feel better. Yeah. Thank you, McKenna. It will be okay. Right. Yeah. And tomorrow, life is still crazy busy over here, but we're doing okay. The dogs are healthy. It's all we care about. No, just kidding. Okay. So the next ones are, personally, I think this type of problem, expanding, not so bad, right? It's just properties of logs. You do need to know them and make sure you do them all, right? So natural log for this one, whenever I have a lot going on, I would start with the top and the bottom. So that's just what I would do. And again, you could do this in one step, but if you miss something, you'll get points out. So I'm going to just say natural log of a to the fourth b minus natural log of the cube root of 8c. And it looks like that's all in there. So there's a few answers I will accept here, but let's just like write it out, right? So the first part I can write as ln a to the fourth plus ln b. And then I can bring this 4 in front, which I'll do in my next step. Then I have minus. Now I can do a few different things here. So I can say ln of 8c to the 1/3 and bring this 1/3 in front. In which case, if you did this, you'd get 4 ln a plus ln b, and then minus, and then we can split up the 8 and the c, right? So I'd have minus 1/3 ln 8 minus 1/3 ln c. Now, if you knew in your head, you're like this is a perfectly acceptable answer right here, right? But if you knew in your head that, oh, cube root of 8 is 2, right? And you wanted to just do that, then you could say 4 ln a plus ln b minus ln 2. You could just so you could basically rewrite this, right, as 2 times the cube root of c. Because it's really the cube root of 8 times the cube root of c. So you could just take the cube root of 8. I'm okay with that. And I'm okay with you not doing that, okay? Because they're both, I mean, technically, it's not right or wrong in the scheme of the question. So I have minus ln 2. Then I'd have, oh gosh, I'm forgetting. Oh, minus 1/3 ln c. So this is also a perfectly acceptable answer, right? What's not acceptable is if you leave 2 of those together, right? I guess one last acceptable answer, sorry, this is a lot, but is 4 ln a plus ln b, and then minus 1/3, and then times ln 8 plus ln c. So if you want to have that grouped in parentheses, I'm also okay with that. I think majority of the time, professors do want like everything written out without parentheses, but I don't care so much. So I would also take, something like this, because as long as you have those parentheses there and the minus here, it means the same thing. So to me, it's okay.
So for the 8 and the c on the bottom, it's minus because it's on the bottom.
Exactly. And the reason, so like notice how in this answer, right? See how it's in parentheses and it's plus, right? Because it's 8 times c.
Yeah.
But because they're both in the bottom, technically this negative distributes to both. And that's why in the answers, when I skip to it right here, I just said right minus, because they're both in the bottom.
Okay. Thank you.
And Jakob says no 1/3. Yeah, you're correct. There's no 1/3 before ln 2 because I took the cube root already. I don't know if that was a question.
Or you put it back, one of the two.
Well, so if you put it back though, you can't. Okay, so it's kind of.
Well, if
you wanted this here, you'd have to put a 3 there, right? Because it would have to be 8 there. So I hope that makes sense. And again, feel free to clarify if that was a question or a statement. Yes.
Yes, it was.
Oh, okay. Yes, and maybe that made sense. Okay, good. Okay. So number 4 is asking us. Now I did just fix this on the test because it printed really funny. Like this is dot product, right? But this is just adding and subtracting, right? So remember what you need to know what the dot product is. I'm not going to have like a formula for that. But just keep in mind that it is different than just multiplying or just adding or subtracting vectors, right? And I did fix it today so that it looks a little bit nicer. However, I think these letters don't look as nice for whatever reason. I think they weren't typed. They're just like, they're not scripty and pretty, but I think here they are. So on the test, I mean, don't stress about that. Just know, okay, U is U, V is V, W is W, right? Okay, so let's take a look. So I'm going to rewrite these. So U is 2, 7, and I'm going to write them in our component form plus, and then I have V which is, which is negative 113 minus W, which is 4, 0. So I'm writing all this out. You do not need to write like all of this, but what's happening here, like I'm trying to make a point that with component vectors, it's different than just typical like ordered pairs or something. Like you don't add and subtract ordered pairs, you know? So in this case, I'm going to get 2, 7 plus, and then over here, I'm going to get negative 1 minus 4 in the first component and 3 minus 0 in the second, right? So this just really becomes negative 5 comma 3, right? And then I add it. I add this plus this, right? So maybe I should have left a little bit more space, but that's what I'm adding together. And so my final answer is then going to be, let's see, 2, it'll be 2 minus 5 or plus negative 5 in the first component and 7 plus 3 in the second component. So the result goes here, and that's going to be negative 310, right? Or did I add that? Hold on, what did I do?
3 or 13?
Oh my God, yeah. Why? I don't, okay, I'm losing it. All right, this is I just changed it from a 3 to a 13. Like, no idea why, no reason. Just felt like I don't need that 1 anymore, you know? Okay, so it is 13 minus 0. Yes, it's 13. And 7 plus 13 is 20. I was like, I don't remember getting 10 when I did this yesterday. Okay. So this is how you would do this. And the answer for scalar or vector, it should be obvious based on your actual answer, but this is still a vector, right? Because all we did was add and subtract vectors. And so we still get vectors. Now notice in part B, I mean, you could answer it right away if you wanted, but in part B, we already see that we're doing dot product, right? So this is dot product, right? And because we see that, we can say, oh, you know, this is dot product. So I know I should get a scalar, but let's see anyways, right? So first, we're going to just add U and V. So I'm going to take 2, 7 plus negative 113. And you could just do it all like this is U plus V, right? So 2 minus 1, 7 plus 13, which is negative 120. Okay, got that. And then we want this dot product. So this dot W. So the dot product with W, which is 4, 0. Okay. So when we do that, and here, maybe I should say this. Dot W. Okay. So when we do that, we're just taking each component, we multiply component wise, and then add this up. So in this case, I'm going to take, you know, my first component, negative 1 times 4. Right?
I think that isn't 2 minus 1 just 1?
Oh my God. It is. Thank you. Hey, at least you're paying attention, you know? All of you are probably sitting at home thinking, this lady, she's losing her mind. What is going on? Yes, this should just be 1. I'm not even looking at my notes anymore. And I should switch to them, and it probably says 1. Let's see. Yeah, of course it does, because that's the answer. Okay. So should have been looking at my notes, but this is, I'm just looking at myself writing like, yeah, that makes sense. It looks good. I wanted it to be negative for whatever reason. So 1 times 4, much easier, but then I have plus 20 times 0 because it's these components multiplied together. So 20 times 0, well, that's just 0, right? So that goes away. And my final answer is actually just 4. So my result is 4. And this, like we said, as expected, is a scalar. And so these are the answers that we're looking for here. Oof, long day. It's only Tuesday, but happy election day. Hopefully you got to vote, you know? Okay. And here's where it will look just like this on the test. It'll say use the appropriate compound interest formula, and it will have both of these, right? So you have to decide which one and how does it work, but they're written on there, right? So don't stress about that. Okay, so the first one says Joey and Bess. I'm laughing because I feel like when I wrote this, I thought of Friends, and that's why I wrote Joey. Well, my girlfriend also just had a baby and named him Joey, but either way, I was thinking of the show Friends or her baby. I don't know. But her baby's not investing $40,000, right? Good old baby Joey with all his money. No, I'm just kidding.
See, Joey is not smart enough to do this.
Well, and then and then like Chandler's got to be telling him what to do or something. But no, okay. So Joey invests $40,000 in a money market account, okay, with interest compounded continuously. Ding, ding, ding. That tells me continuously I got to use this, right? That's what that tells me right away. And it grows. Oh, wow. Okay. It grows to 150,000 in 18 years. Okay. I mean, I don't know. That sounds good. Oh yeah. You're saying, okay, sorry, all you young. Hey, well, at least I'm old enough to get that.
There was a show called Friends.
Yeah. So for all of you young, all of you people born in what, like 2000 or later, which is scary. Yeah. But before your time, there was a great comedy like series called Friends. Look it up. No.
It's on HBO.
Oh, is it really? Yeah, I don't even know. But I just see reruns, right, all the time. I feel like it's always playing, but it's playing
It's always on. It's
always
every day
on like Comedy Central or something. But at weird times when
it's on Nickelodeon.
Oh, interesting. Wait, crazy. Okay, I don't watch Nickelodeon now, but I'm sure, I will at some point when for children or something, but that's so funny. Yeah. Oh yeah. Okay. Yes. Yes. So Joseph's got it. Your love life is DOA. That is part of the song, the intro, right? We'll have to, you know what? The last day of class, maybe during your final exam, as people are coming in, I'll just play the intro to Friends, and we'll just all be happy, right? How are you not happy about that, right? The song's called like "I'll Be There for You." So all you youngins, like, yeah, and you're 22 and you still not 21. Wow. Okay. All right. Stop making us feel bad, Joseph. I mean, I'm just kidding. Okay. All right. So let's calculate some of this. So find the interest rate, round to the nearest tenth of a percent. So in this case, first let's write out what we know, write the formula, and then we'll solve, right? So he invested 40,000. So this is my P, and it grew to 150,000. So that's my A. T is 18 years, and R is a question mark. We don't know. So now we can write this out, and we can say, okay, maybe I'll switch. 150,000 equals 40,000 times E to the R to the 18. Let's do 18R, right? And so first step is we'll divide both sides by 18,000 or 40,000. Oh gosh. Okay, divide by 40,000. And I think it's like 3.75. So you can just leave that as a decimal. And this is E to the 18R, right? So now we take, you could do log, but I'm going to do natural log, right? Because it's easier in this case. So we take ln of both sides, ln, and we bring this into the front. So I'm kind of doing multiple steps. I think it was McKenna or a few other people that have requested every step. So if you're like falling behind, just let me know. But so I bring that in front, and I'm going to write an ln of E is 1, right? So I'm just going to have 18R equals ln of 3.75, right? And I drop the ln E because it's 1, good to go. And now I can divide both sides by 18. And so R is going to equal ln 3.75 divided by 18, right? And that is approximately, I'm going to write a bunch of decimals because I think 0.0734 is what I want to write, because then they want us to round to the nearest tenth of a percent. And so we need to translate this into a percentage. It would go 2 decimals to the right? Because normally they give us the percent and we have to change it and move the decimal 2 places to the left, right? But in this case, we want to move it 2 to the right because we get our decimal. And so in this case, my answer then will be, so answer equals 7.3, and this 4 means I don't round it up. So it's just 7.3%, which, man, that's like mortgage rates at this point for houses. No, I mean, instead of interest rates for savings accounts. But hey,
It's true.
welcome to the future, right? No, I'm just kidding. Okay, so the next one is going to be a little different, or I think we're not solving for R, but I think we're solving for T. Yeah, nearest year. So you inherit $75,000, don't you wish? And you invest it in an account that's earning 3.5% interest, compounded semi-annually. This makes a little bit more sense. I feel like that's like sort of more accurate, but semi-annually means here, and it tells me that n equals 2, because semi-annually, twice a year. There we go. Determine how long it will take the money to grow to 120,000. So we already have 75. So we're just trying to figure out, that's not even double. So, maybe it won't be too long, but maybe it will be. Let's see. So we're going to say, let me label everything. 75,000 is the P. That's what we initially invest in. 120 is our A. That's what we want. R is going to be 0.035, right? And T is a big old question mark. So now we can say, okay, 120,000 equals 75,000 times 1 plus 0.035 over 2 to the n times t, so 2t. And so we divide both sides by 75,000. Right. Sloppily, but nevertheless. And it should be 1.6 on this side. And then I did just add, so you do not need to do this. I just did this, I don't know if it's helpful or not, but I did add that 1 plus 0.035 over 2, and I got 1.0175. Now, I don't know if it's more annoying to write that or write everything that's in the parentheses, but either way, then it's to the 2t power, right? And so now we can take ln of both sides. So that's what I'm going to do, ln. And you could take log as well here. It doesn't matter. You're going to get the same answer. Just stick to your guns, whichever one you pick. And my new equation here is going to be ln of 1.6 equals, now I will bring the 2t in front, but this time I can't get rid of that ln because it's not e, right? So it's 2t ln of 1.0175, right? And so, okay, now I'm going to be writing in the next thing, but I'm going to divide both sides by 2 ln. So I'll write it here, 2 ln 1.0175. And then I'll divide this side by 2 ln 1.0175. And the reason I'm doing it with the 2 and the ln is because I want to get t all by itself. Oh, yeah, Michelle, sorry, I'm just seeing your comment. I want to know what bank does this. Yeah, so do I. If I find out, I'll send out a message in Blackboard and tell us all to invest. However, I will say, and I don't know anything about finance really, but my husband did find years ago, like a savings. It's like one of those like better savings. I think it was Marcus or something, Marcus savings account. I don't know. And their rate was really good. And then, COVID or whatever happened and it crashed like everything else. And then it's slowly going back up though, probably because everything else is inflation. But it's up to like when we first put money into it, it was at like 5% or something over. And it was crazy high for like a savings account, right? But then it went down to like under 1%, like everything else, right? But I think it's up to like 3 or 3.5, or might be 3 right now, or 3.5 even. So Marcus, MARCUS, I don't know, look it up. I don't know what they do now, but okay. So Michelle, maybe that's some research for you that you can do. And then you get back to us and let us know. Did you create an account? Is that the percentage, right? Okay. So when we divide by this, let me rewrite it just a little bit nicer since I've like basically butchered it over here. But basically this cancels, right? And then we get t, but I'm going to say t is going to equal ln of 1.6 divided by 2 ln of 1.0175. right? So once you put this in your calculator, and again, make sure like you close those parentheses there, like just be careful about all of this. And we say I was getting about 13.55 or something, 545, something like that. And it does say round to the nearest year. So we can just round this up, right? And we can say in about 14 years, their money would be where they want it to be that they invested, right? So although that sounds maybe like kind of a long time, it's not really. It's not, time flies. Okay. And so this, I mean, I clearly copied a picture from the internet and I did this for the test as well. And then like you can see here, just put different numbers because there was like something random there. So let's hope that this works out. I really like to think that I made sure this one did, but okay. And then I also made up this like problem to actually be Austin things, but like totally inaccurate. Like this is not.
It's not far off.
Oh, is it not? Okay. All right. Then I tried really hard, let's say, and I made it almost exactly right. But okay. But so, we can just tell ourselves it's really close. So from a point along Congress Street, let's say the angle of elevation to the top of the Frost Bank Tower, right, is 44 degrees. So what they're saying is from some point, and we're pretending that's here, the angle of elevation is 44 degrees that they listed there, right? And we don't know this point. We're just saying at some distance away from the building, who knows how far. Then from 850 feet farther from that point, so this point, we do know this 850 feet down the street, so still on Congress, I guess. Except now I'm wondering if it made more sense if I said like 4th or something, or if I, instead of the Frost Tower, if I said like the state capitol or something, but either way, it still works. Okay. It still works. Yeah. Okay, good. I'm glad you thought about this as much as I did. Okay. On your test, I got to say it's probably from your textbook and it's not Austin related, but at least on here, I could have one. The angle of elevation to the top of the building. So from that new point is 20 degrees. So again, they give us that 20 degrees, right? How tall is the building? Ground to the nearest foot. Okay. So what I'm going to do is make this line here, which maybe I should do like, I really wish I could save colors. I'm sure there's a way, but you know what? It's too little too late. So I'm going to make this line here. And this technically is what we're looking for. Like I labeled this as X. You could have said H for height, but this is what we want to know. We want to know how tall is that building, right? And then I started to label some other things because we need to try to start figuring out like, what can I use here? I see that this is a right triangle, but I don't know enough right now to do like right triangle trig. Like I don't, we don't know any of the sides of that triangle. So that's not going to work. Right. And so, but maybe if we got this side, which maybe I'll call A, or you call it anything, but I called it little a. And then maybe I called this side little b, and I called this side little c. So if that is the case, right, and if I wanted these angles, so now I'm thinking instead of right triangle trig, I'm looking more at, so Jakob, you, in this problem, even if we could get, so let's see all the information that we could get without calculating anything, and then I can explain the answer to that question. So without calculating anything, we do know that, let me highlight it, that this line, it's a straight line. So this should be 180 degrees. So if we subtract 44, we can get that this is 136, right? Okay. And then we know this is 20. So if we do 180 minus 136 minus 20, this gets us this little angle in here, which is 24 degrees. Okay. Like, I mean, we're getting somewhere maybe, but the thing is, we don't know if we knew this whole angle up here, we could subtract the 24 and get this angle in here and do right triangle, or like, maybe some type of right triangle thing. But again, we still don't have any of the sides. We don't have any sides of that triangle. So since we can't do that, what we might be more interested, actually, we can even get this angle. Oh my God, I'm lying, because it's a right triangle, right? So why did I not see that? So 44, this is 90. So we can get this angle by just doing 180 minus 90 minus 44. And it's actually 46 degrees. However, that still doesn't help us because we still don't have any of the sides. So this is where Jakob's question comes into play, because if to find x, if I knew either this length or this length, I would just do right triangle trig, because I don't even need anything over there, right? Because I have everything I need just in this little space. But because, and they did this on purpose, right, in the problem, because I don't have any anything here. I don't have any sides. I only have a bunch of angles. So because of that, I'm going to need to use some type of law of sine or cosine, right, to figure this out. And cosine, the law of cosines, I think you could use, but I think it's easier to use law of sines in this case, right? It would be actually, oh wait, you need to know a side, I think, for that, 1 or 2. So I actually don't think you'd be able to do that. So yeah, so we're going to use law of sines here because we do know the only side we know is this side right here, right? We don't know this one. We don't know this one. We don't know the bottom. We don't know X. So we don't know any of these other ones. But because we know little c and we know the angle of it, right? We can say, okay, like, so law of sines says like a over sine A equals b over sine B, or it could be c over sine C, right? So I'm going to use c over sine C. So 850 over sine of 24 degrees has to equal. And then you can really pick what you want to do, but I solved for A because then I could use right triangle trig to just solve for X. If you solve for B, you'd still probably have to solve for A, or you'd have to do some type of other. Actually, if you solve for B, you could use right triangle, but you'd have to get this distance here so that you'd be using the right triangle here. But it's more complicated, right? So you don't want to do that. So instead, we want to solve for A. So we get little a over sine of 20 degrees. And then I just said, okay, so A is 850 sine 20 degrees over sine of 24 degrees. And this is about, 714.76 or something. Okay. And I think it's in feet technically, but so now what we want to do, use y equals sine 20 times 1/4. Where are you getting 1451 from?
I solved for B.
Oh, you solved for B, and then you just did
Exactly.
sine of 20 is opposite over hypotenuse. I see. So this is also, okay. So actually, yeah, you don't even need that bottom piece. That's true. So you could have solved for A or B. So let me just recap kind of what, so if you did, and we should get around the same answer. So if we don't, Jakob, let me know, but you could do this, B over sine of 136 degrees, right? And you would solve for little b, and Jakob is saying he got 1451.
It's like the hypotenuse of the big triangle.
Exactly. And so it's the hypotenuse of this. And I forgot we have the angles. I don't know why I wasn't thinking that. So then if you want to find X, he used B, 20, and X, and he did sine, right? So then he did sine of 20 degrees equals X over B. And this guy is B. So you just multiply that by sine of 20, which that also should be right. Okay. And you actually, we get the same answer. So, but let me show you what I did. And again, neither of these are wrong. They're actually, they're both right. And you can use whichever way you want, right? So I got A. So I got, let's maybe do a little, not red. Let's do it's like different from blue maybe. Oh, is that too dark? Maybe, but here we go. That's fine. Okay. So if I did A, like I solved for A, and then I focused on this triangle and I used 44, A and X, right? So my equation is going to be sine of 44 degrees equals X over A, which was 714.76. And so X is going to equal 714.76 times sine of 44 degrees, which I'm getting approximately the same thing, 496.5, the same thing that Jakob got. And they say round to the nearest foot. So we'll just say it's about 497 feet. Yeah.
And when I
Perfect.
looked it up, the actual height of the Frost Bank Tower is
Okay.
515.
No way. Oh,
Yeah.
that's so cool. Okay.
It's pretty close.
That I should totally say I did that on purpose, but that is actually kind of awesome. Okay. Even though for those of you that are like, why, who cares? I'm sorry, but that was exciting. Okay. Because I was just excited to put a little Austin in a problem. You know, I'm like, oh, I could actually, if you're in Congress, I'm like, what building do I know that I always see? Like, I feel like the Frost Tower, you could just always see it, you know?
Yeah,
and
it's getting shorter though.
well,
Compared
okay,
to,
you're so right. It's okay. Clearly, I don't drive into the city as often anymore.
Yeah, it used to be the tallest building for a long
It
time.
did used to, right. So for a while, whenever I when I picture driving into the city, right? Like, I don't know, in the Star, I don't know, I just see it. But but my husband used to always get so mad because one of his offices is in that building, and I used to always call, when we first moved to Austin, I called it the Robert Frost. I was like, it's the Robert Frost Tower. And he's like, it's not though. He was like, it's the Frost Bank. And I was like, Robert Frost, there it is. And like the poet or whatever. And he was like, no. Again, for those of you that don't get that reference, sorry. Okay. So now here's where I wrote some things down that we're going to do here because I should have just printed them for you, but I was being slightly lazy. But so everything on this review you need to know for the test, but also for the test, the force work problem and finding the true speed and bearing, which is what we did last class or last week, all week. Now I'm just going to reference some examples. And then I don't know if we're going to do those exact examples. I can't remember, or we're going to do different ones, but the examples I'm referencing are example 8, section 8.5. Oh, this is from the notes, page 14. I think, or page 14, page 4. I think this is from the notes, page 4 of 8.5. So really it's probably later, but example 8 and 8.5 is what I'm referencing from your notes. And these are the notes examples. So the other one was example 14, section 8.4, and I wrote page 6, but I'm actually wondering if I was supposed to add these and they're not there. So now I'm all second guessing myself. So let me pull up maybe let me pull up those example homework problems that I wanted to do, or they're from your book, but they're 8.4 and 8.5. And I just know I wanted to do them and I can't remember. Okay, so they're similar. Okay, so they're similar to these two examples that I just named, but these were from your notes. Or maybe they are the same. I don't know. Let's take a look. Okay, so I'm gonna save this unless there's any lingering questions about the problems we just did. Okay, I'm taking that as a no. I'm going to save this.
Oh, it's like example 14 and 15. It might be example 15. But
Okay, it might be example 15. All right, well, wait, let me cancel maybe, and then let me fix this. Maybe it's example 15. I might have renumbered, and that might be why. Okay, so let's save this. So I will post this whole thing tonight. Save it on my iPad. Test reviews, I guess. All right, save. Okay, so test reviews. Well, now what was I going to do? Oh, now I just want to get, okay, bear with me because I'm like so bad. Okay, I just want like a blank file. Is that how I can do this? Yeah. Okay, and we'll do, okay, perfect. So this is going to be, is this working? Yeah, okay. So, oh no, what is going on? Okay, that one. Wait, okay, my pen's being super weird. Do you think my pen's dying? I just plugged it in for like 10 hours. Okay. But notice how I can't go back. Oops. Like I can't erase what I just did. Oh, whoa. All right. We're gonna do our best here. But okay. So I want to do, oh, no. Okay. Maybe I want to do this. New note. And let's call it. Oh, do you hear that? Oh man. Test 3.
Yes.
Yeah, that's quite loud. I'm sorry. Okay, let's try to get rid of this. How do I just do? Okay, here we go. All right, let's hope this works. So test. Oh my god, I feel like it's. Oh, okay. We're just struggling here. Okay, so 8.4. This is section 8.4. That's why I'm writing this. But it's exercise. I think it's from your book, and I want to say.
The problem number?
Yeah, it's 95. I want to say from your book in 8.4. I don't remember if it was in your assigned homework or not, but regardless,
There was a problem in Alex like that.
Okay. So we're gonna take a look. So I'm gonna write it out and just bear with me. I should have again prepped this better, but 2 pickup trucks, rescue. I can't spell. Rescue a car stuck in the sand. First truck. Oh my God, perfect. Somebody, thank you, Jakob. You typed in the chat. But okay, maybe I'll shorthand the rest. First truck pulls 4,000 pound force, because this is important. Second, 3,000 pound force. Angle is 35 degrees, right? Okay. To the first truck. Okay. Now we want to know force. I guess I'll just say force needed, but you can see if you guys check the chat, Jakob said, don't try this. Don't try this at home. You could try this exercise as a problem, right, in math class, but yeah, definitely don't try this in real life. But the question is, how much force can the combined pull of the two 50-degree trucks generate? Okay, so then, I don't have the 50-degree in my problem, but that's okay. Maybe that comes later, or maybe mine was 35 and yours was 50. I don't know. Okay, so force needed, or combined force needed. Like, what is that? Right, that's what I'm gonna say. Okay, so let's do this. So I'm gonna draw a picture, and it's gonna look ridiculous, but we're gonna have like car stuck in sand, right? Okay, there's the dying car. Or maybe that is. And so truck number 1 and truck number 2, or maybe they're something like this, right? Here's truck. And one of them, they said, is 4,000 pounds. The other is 3,000 pounds. Wow, that just sounds like a lot. And this angle is 35 degrees. So as vectors, right? As vectors, the truck is 4,000, 0, because it's pulling. We're assuming that it's pulling just straight, because it says the 35-degree angle is to the first truck from the second truck, right? So the second truck is pulling in a 35-degree angle from the first truck. And so the vector here is actually 3,000 cosine of 35 degrees and 3,000 sine of 35 degrees, right? Because it's at this angle. Oops. Okay. Now, again, I'm not saying that this problem is just like your test, but I think it's just, it's similar to questions in 8.4, and then 8.5 we'll do another. And I think it's just an extra one for us to do besides what's in your notes. But I do recommend looking at the ones from your notes too, because I think your test is a lot like those. Okay. So from here, and notice, so this is a force problem, not a work problem. I do think on your test it's a force problem as well, but I did say to like refer to a work problem too, like just in case, but I think it's just force. And then your, I mean, they're quite similar, I guess. And then the 8.5 is the bearings and the speed and all that. Okay. So then we want to get a combined force, is going to be the two added together. We just add them together, right? So 4,000 plus 3,000, and I'm still just writing it as 3,000 cosine 35, and then comma, 0 plus, sorry, I'm running out of room, which I probably could have changed that, but 3,000 sine 35 degrees, right? So this is the combined force, but in order to get the actual combined, how much force the combined pull generates. Okay, so maybe I wrote this question wrong. It's how much force does the combined pull of trucks generate? Right, so what that means is we take the combined force vector, and to solve for this, to solve for the force of the trucks, we take the magnitude. Of our force vector, which I'll let this, our force vector is this combined force, right? So, so again, this is like, I mean, it's not crazy, but okay, we have to do the magnitude of F, which is the square root of 4,000. I'm being so lazy, but plus 3,000 cosine 35 degrees. I could just figure out what that is, but squared plus 3,000 sine 35 degrees squared, right? So it's this, and it should be about like, I don't know, 6,000 something, 6,682. Does it say to round? Oh, it said to round to one decimal place. That's at least what your book said here. So, and it's pounds. Is that's right?
Use INJ. Yeah.
Oh, wait. You used INJ?
No, the textbook give this question.
They gave it in INJ. I see. Okay, so your textbook gave it in INJ. So instead of what I did, I mean, they just had, right, like this was the I parts, right? So this was I, and then the J was this guy, and this guy, and this guy, right? So yeah. And then from there, you would just take the I component, square it, add the J, the coefficient, square it, and then you just take the square root of that. So it's the same thing, but yeah, thank you for letting me know your book uses that. And I don't care which one you're going to use on the test. It's up to you.
You can, in terms of I and J or not.
Yeah. So you can, and if it's not, it's just make sure it's in these vectors. It's technically a vector, right? But yeah, but I'm not
if
concerned.
INJ is doing nothing, why we are
okay, so the INJ doesn't do, no, it doesn't really do anything, but sometimes
just like
it's confusing probably, but sometimes they just like it to instead of writing instead of writing it as, for whatever reason, instead of writing it as this thing, they can write it as like an equation with variables. And I think that's why a lot of like math books and things, they like it, because then it looks like an equation, even though it's really just a vector. So very bizarre. And yeah, I'm not totally sure why, but we would say here, so the combined pull of the two trucks here, or can generate 6,682.8 pounds of force. That's what's being like, that would be like the answer. I think that your textbook kind of gives it as like a sentence, right? But on the test, I mean, you could just tell me 6,682.8 pounds. You don't have to write a sentence. If you want to write a sentence, fine. You don't need to. Okay. So this was just, again, another example. And I think like if you go back to the homework and look at those, I think that should be helpful too. But then the other one that I just wanted to look at was for 8.5.
So should we look, let me ask you a quick question on before we go to the bearing one and all that.
Mm-hmm.
So this one was just asking for the amount of force in pounds that was generated, but should we also look at the ones that look for like feet pounds or that's
work, right? Those ones. Yeah. So again, let me get more specific with you and look. I took notes on something else before. I hate being this person, but I have so many tabs open right now on my computer and it's crazy. I don't want to jinx it, but now I will. We did get Wi-Fi extenders and like a new router this weekend. And nice. I think, and notice how I didn't lose you yet tonight, right?
Yeah,
and
the Wi-Fi
I'm gonna
extenders.
Yeah. So we're thinking that's going to help because for both of our video calls, we would just lose. And we started working from home more. So it was a nightmare. Like I'd be in the middle of a call with my manager and it would drop. And then like my husband would do the same thing. And it was just, and then like every class, literally every class since the last month, like we just dropped at least once,
Since you moved, basically.
Yeah, since I moved. Exactly. So here we are.
So what gave you the idea to do that? Just wondering.
I contacted our internet provider like 300 times and then it was really frustrating. And finally I called them on Sunday and I was like, look, what can you do for me? Because this is just unacceptable. And we found out that one of the rooms in our house actually got no internet. So it would literally just
then
drop.
You're like, how do we get it in there? And then it kind of was like, ding.
Well, yeah, I was like, shouldn't this cover our whole house? Like, I don't understand. And I did go to bed. So basically AT&T is our internet. And they were like, and of course they're the only internet service in our whole area. So there's no options, right? But they did say that, careful, the fork is in there. Did you take it out? They did say they were like, oh, we can charge you another however much a month, like $10 a month, and we'll put in Wi-Fi extenders and install it for you. I'm like, you have to plug it into an outlet. Like, what are you installing? And then I looked them up and they don't, they maybe cost $50, maybe $100 for a fancy one. And I was like, why would I pay $10 a month forever?
Oh yeah. Ridiculous.
I was like, no. And they're like, well, they'd be under warranty. I'm like, what? No. I was like, they'll probably break them. That's probably what that means. So then I just Googled it on Best Buy and I went there and I talked to a guy and he was like, okay. He's like, here's your options. There are different Wi-Fi extenders, but here, fun fact for all of you that are interested in this, and sorry if you are 21, you probably don't care right now, but because you're probably like, I have Google Fiber.
Now you can watch Friends anywhere you want.
Yeah, right. But they basically told me that it probably has to do with the modem is fine, but it's probably the router. And they were like, it's probably not a good router. But he said, if you get the Wi-Fi extenders, they should work. But the issue is if your router isn't good, then the internet speed that you have, which is probably great just from your modem. He said the extender will only extend the actual internet connection and it won't extend the speed. So he said, in order to extend the speed, of course it was like $100 or $150, whatever. But
that's an ISP issue.
But he said it's Google product. I got a nicer one. They have different brands, right? But it's a Google product and it's a router that you plug into the Ethernet of your modem. So you have your internet all connected. And I asked him, I'm like, is this going to affect? And he's like, no, you plug it, you plug the router in, plug it into the Ethernet of your modem, and then you can plug in an extender that matches with this router, and it will bring the speed and the connection to your room. So far, fingers crossed, it's only been 2 days, but we're already both like, it's so much better, and then
it's super. But it's perfect. That's great. Thank you.
Yeah. So I'm really glad it's been good for you guys. Yeah. The next few weeks will be so great for you. I apologize for all of our horribleness before that, but blame AT&T, right? But okay. So anyway, yes, I would look at the force and the work problems. But as I was saying, I'm looking at my notes now just to double check what we see here. For the test, I see. So yeah, so like the feet pounds, or did we do any Newton meters or something like that?
Either
So,
way.
yeah, either way, look at one of those because there is potentially a work related to this, right? And then and actually there might actually not be one like this force problem, but it was good practice. So oops. But there's that like work one, and then there's like a true bearings and speed, or speed and bearing one. So which we'll do right now. But good question. And you're keeping us all just consistent over here. So 8.5. So from this section, I'm looking at exercise. I don't actually know which one this is. Oh, it's similar to 37 and 38. And I actually think it's number 7 in your homework, I think. So you probably have already done this. And if you haven't, here you go. We're about to do it. So awesome. I don't know if you'll have different numbers than me, but find the angle. The question is find the angle between vector V is minus 9.2 and W, which is 8. Oh, how gross. 8 negative 12. And then if you need to, it says if necessary, round to the nearest tenth, but okay, maybe we don't need to, but maybe we do. I don't know. So for this one, this isn't even true speed and bearing. Sorry, this is an angle between. So it's related to this formula. And let me, so I would also, again, I would recommend, and we can pull up the notes maybe after this problem. I would recommend looking at a true speed and bearing question, and the test is probably just like the notes. So that one we did there, I would just check that out. Okay. So then we have V, and there's probably actually speed and bearing ones in the review of the book problems, right? I can almost guarantee there's like one of those. But okay, so if we want to find this angle in between, we can actually use that formula that we have. The dot product equals the magnitude, of this vector times the magnitude of this vector times cosine theta. So remember, and I don't actually think you'll need this formula on the test, but it is not given to you if you do. But again, look at the speed and bearing. You may still use it in that case. So from here, we can actually get these separately. So we basically get this side, and then we can write this side and just set them equal, right? So dot product with W is going to be, and I'm looking at these components multiplied with this component and then added, and maybe I'll get the signs right this time. So it'd be 9 times 8 plus 2 times negative 12, right? So that's, 72 plus or minus, I guess, minus 24. So this is 48. Okay. So this is 48. That's our dot product. And then we can find magnitude of V is the square root of 9 squared plus 2 squared. So square root of 81 plus 4, so 85. And then magnitude of W. And you could write this all together. I'm just doing them all separately and then write them together. So this is square root of 8 squared plus, the negative doesn't really matter, but negative 12 squared. So it's 64 and 144. And that is square root of 208. And these are decimals. These, don't bother like simplifying. We'll just kind of calculate this all, right? So what we'll do is to go here, we'd say 48, which is the dot product, right? That equals the square root, and I'm just going to say 85 times 208, because that's all in the square root together. We can just write that as 1, and then cosine of theta. So then what we can do is we can divide both sides by square root of 85 times 208. And this is where we are going to get a decimal, right? So we'll have to figure this out. So these will cancel. We'll get cosine theta is 48 divided by the square root of 85 times 208. And so then we take the inverse cosine of both sides, right? So I'll do inverse cosine, and I'll probably keep all of this together. And this is going to equal theta. And I think we get like I don't know what round to 1 decimal. So the angle between, and what we're looking for, like, so if we were to draw these, granted, I didn't like do that, but if we were to draw these component wise, you know, okay, they wouldn't look exact, like maybe V is over here, maybe W is over here. And we're trying to figure out if we connected these together, like these start points, and we created this, right? We're trying to say, what is this angle in between if this was W and this was V, right? And that angle is about, so that was not drawn to scale, but I got 68.8 degrees. Yeah, Jakob, you're correct. Good. So again, I guess I wanted to go over this, I think because of homework maybe, and maybe we didn't do it last time, or I'm not really sure, but I do want to mention the bearings and speed. Definitely take a look at that. I didn't prepare another one, so sorry about that. Drop the ball maybe, but also I don't want to maybe give away everything on the test this time, but yeah, I should be. I mean, that should be it. And I did decide, I mean, if you really want it, again, I can post this, but I did decide I'm not going to do the 2.2 review on circles because it's not on the test. And I don't think we even use it in the next section. But if it comes up, I mean, we can always kind of sneak it into a class. Oh, maybe we kind of see, we look at equations of circles and stuff like next section. But I think maybe what I'll do is I'll fill in the notes and post them for you guys. And then if you do want to like talk through them or you have questions, just let me know. But I don't think it's going to be like so relevant for you right now.
What about there's a few other things that like I'm like calculating the population or
so none of that will be on the test.
Okay.
I don't know if that was like the decision. I mean, I did have to pick problems and stuff, but I was shown a test from previous semesters and maybe they just leave it out of test, but leave it in the course, right? Like, and also, I mean, there's also things from your book that we don't cover, right? That are just kind of skipped over, right? Like even the projection equation that someone was talking about earlier, but
writing the model for displacement of a spring.
Yeah, so that is not, so although we did do that and there were, I think, homework questions, right? That is also not on the test. So, so I don't stress about that. And I guess if there's like a chat going on, it is everything we covered and discussed today and nothing more really. You can, I mean, feel free to, yes, even though the review, that's the other thing. So McKenna, good point. Like the other thing about pre-calc is there's so much like going on, right? And although, we could test everything, but I think the things that are tested most, or at least that I thought would be tested most, are what is potentially going to then relate next year or, next time to calculus. And again, in calculus, you almost don't even need to know pre-calculus, like barely, like you don't, well, okay, you need to know it at the beginning. And I will say, maybe I spoke too soon. The beginning of calculus, maybe like the first 2 or 3 weeks when and you get to limits and you're doing like pretty intense definitions and like there's a lot of memorizing. It is maybe the most difficult part. But then once you get to integrals or derivatives and integrals and this type of thing, there's just shortcuts everywhere. There's just a shortcut. There's just shortcuts and shortcuts and shortcuts. And it's just, I mean, yes, you should know why, but the why is the pre-calculus part, right? And so I will say like, the shortcuts, I mean, make it seem a lot easier. So So yeah, but I don't know why those things aren't on the test, but they're not.
What about these problems where they're like, calculate the height of the window, I mean, we kind of did a problem like that, I guess.
Oh yeah. Okay. So I don't think that's in there either. I will say the only problems that like word type problems that are similar to what you're asking would be finding like the height of the building, like what we did today.
Mhm.
Finding force or finding work used to like pull something or push something.
Mhm.
And then finding the true speed and bearing. And now I'm starting to think maybe I even like left a page out of it, but too little too late. If that is the case, then we're missing a few problems, but it'll be okay. Cause that's on me. But yeah, so those are the only like, and then aside from that, it's law of sines cosines and log properties and solving exponentials like that and that type of thing, compound interest. So there's enough. I mean, there's a lot on there, right? But this, yeah, I don't know if this unit.
Well, there's only so much you can do in an hour,
and that's the other thing. Like we don't want, and especially, yeah, I think it's just like a matter of, also timing. And it's like, okay, if you had 3 hours, we could test every single thing, but then who wants to even sit or grade a 3-hour test? Like not me. But yeah, and that's what the homework, I think that's also really what the homework is for, right? Even though you have unlimited tries on the homework, but the point is like, if you can get it and understand it, then not that you're being tested necessarily, but it's like a test, right? You just get multiple chances to figure it out, right? So yeah. And yeah, Michelle, I see your sad face. I don't remember why. I don't know what I said for that, but maybe it was calc related. Or the fact that pre-calc is just hard. But yeah, and I'm typing like spaces here. Oh, geez. I think I just deleted this all. Oh, undo? Oh, that's a relief. All right, let's figure out how to get out of this. Okay, perfect. All right, well, I will try to, let me just get out of this before I mess something up. All right, we'll just, I don't know how to get rid of this. Yeah, I really have no idea. All right, we're just going to do that. Okay, so yeah, I'm going to stop sharing. I don't think there was anything. Oh yeah. Oh, Joseph, thank you. You've always got our back, Joseph, I did figure out how to get it back up though. Yeah. Man, those young tech savvy folk, they'll cover it
comes naturally.
Right? Yeah. Now we're always going to call you out, Joseph, as the young techie for us. But I will post, the notes tonight and from class. And if there's any like other test questions or anything, I mean, feel free to email me tomorrow. I'll be working, but I'm actually, my day's like semi-busy, but not too bad. We still have, man, this house is crazy. We have people coming for our garage tomorrow. We have landscapers coming to fix some of our beds. And we also have a shower person coming to start doing work in one of our bathrooms. So they're literally all coming tomorrow. So
wow,
the house is going to be chaos, but it's going to be good.
And you're working at the same time.
And I'll be working. Yeah. And the dogs will be barking the whole day for 8 hours. No,
so
I'm kidding.
I have a question that hopefully it's something that is can easily be explained. But so the problem we did on 8.5, we used cosine, but I see a problem from our notes that we used cosine and sine. So how do we know like when to use what?
Yes, let me pull up. Okay, so can you reference the problem in your notes?
Yeah, so it's problem number 10.
Okay, 10 from 8.4 or 5?
Yeah, that one is from 8.4.
Okay, 8.4. Sorry, let me just scroll through. Problem 10. Okay, so problem 10, we did. Okay. So for problem 10, I mean, and I also actually don't think this on the test, but problem 10, we have cosine and sine because we were looking for A. Is this the AI plus BJ problem?
Yeah.
Okay. So we're looking for A and B, and A is like the I is related to cosine and the J is sine. But the problem we did today, which, well, now I don't have it. Let me
I think that was from 8.5, but I thought I saw something in the notes also where, so problem number 4
from today.
from 8.5. Well, from the notes.
Okay,
So
okay, sorry, 4. Got it.
So that one's asking to find an angle between the vectors. And for that one, it looks like we only used cosine.
Yeah, and that's because we used, so for this problem, see how in this problem they gave us V equals negative 2I plus 3J, and I should just share my screen because this is going to make way more sense. Hold on, give me like a hot sec here. Desktop, how do I, okay. Of course, I can share on an iPad. I can't figure it out on my computer. Oh no, oh my God, I thought I just lost internet. My whole world crumbled in front of me. Now this is another woman's solution. This wasn't mine, but it should be similar. Where was it? Here, right? So see how in this one they give us negative 2I plus 3J and 3I plus 4J. So they already gave us the A and the B components, and we don't know the angle in between. That's when we use this formula. And that's why cosine is just a part of this special formula. Okay. Whereas before give me a sec. And these are all like mislabeled, so it's confusing. But this one, so it says, write the vector in the form AI plus BJ, where the magnitude is this and the direction is this. So they gave us the angle and the magnitude, and we know that little a is the magnitude cosine and little b is the magnitude sine. But notice how, in this problem here, if we wanted to compute it, we could have said like this negative 2 and 3 technically is the magnitude of V, like negative 2 should be equal to the magnitude of V times the sine of theta. But we don't know theta in this case. Oh, sorry. I'm confused. The same thing for 32 in the book review. Question 32 in the book review. Okay. Okay. Maybe I can go to Blackboard. I was looking at your test before, but maybe I can go to review. Okay, let's see. And of course, now you can see everything. Test 3 book review. This one, right? Okay. Yeah, and clearly the internet's not perfect, but at least it's working. Okay, so 32 here. Okay. Okay, so here they give you V, find the magnitude. Okay, so for this one, they're all of these problems are like sort of related, but kind of different, because this problem, what you're going to do is to get the magnitude, you're only given one vector here, and to get the magnitude, we just do 22.2 squared plus 18.6 squared square root of that. Are you with me there? That makes sense. Okay.
I did. But
okay, you did that, right. But then for the angle, you have the option here of doing.
I use tangent.
You can do a few things, right? Now, one thing you could do is 22.2 should equal the magnitude that you found in part A times the cosine of theta, and you can solve it this way. Or you could do 18.6 should equal the magnitude, again, of V times sine of theta. And then from there, you divide and you take the inverse sine or inverse cosine and you get theta, if that makes sense. It is in degrees though, which
I use tangent.
Tangent of theta is B over A.
So. Or you do that. Oh, okay, sorry. I was making it way more complicated. So, or you do tangent, which I forgot about that equation. So tangent theta is B over A. So you do tangent is 18.6 over 22.2, and then inverse tangent. There you go. Yeah. So this was a different, so it's not, so in these cases, it's not necessarily we use sine or cosine or we use this function all the time. It's kind of like, what do they give you? And then what do we know? And what can we figure out from there? Hopefully that makes sense. And I forget who asked Michelle. No, Veronica, Michelle, who asked the first question? I can't remember.
It was me.
Oh, Veronica. Okay. So I just want to make sure, did that kind of help?
Yeah, I think I just need to work on them more and get
Okay. Yeah, and I will say, I mean, for the test, there's not a ton of these. Like there definitely could have been more, actually, probably, but there's not a ton of them. So do some more practice, look in your notes or like maybe pick out some of these homework problems, give them a try and then check the answer. Cause the answers are, and I'm sorry. I didn't remember where I posted anything. So in completed notes and solutions. So tonight I will post what we did tonight, but I also did put these test 3 book review answers. I didn't remember where I put them last time. So I just put them here. So if you want to see, like, if you're working on this and you're like totally frustrated, you can see, and the formulas that will be provided are just the compound interest formulas. Other than that, like for force or work or anything, like you do need to know that. Granted, if somebody messaged me on the test and was like, what is this? And then I just looked it up and decided to type it in the chat, I maybe would make an announcement. But yeah, but hopefully everything else, it's really just those compound interest ones. So definitely take a look at these answers if you're doing, I mean, I know there's no really work here, but at least this should help you like be able to work backwards to figure out. And then I know that you guys are one of my best classes with like active, like chat and like group, all of this or whatever.
Mm-hmm.
So, if you guys message each other, I know you guys help each other. So that's really good.
Yeah, I've done all these. So if anybody wants to know how to do it.
Look at that. Michael's ready to go. Ask him the hardest questions.
Ready to provide support.
Yeah. Ask him the hardest questions and he's going to teach it. Right. And
Michael's the honorary TA pretty much.
Yeah, I mean, that's amazing. That's perfect. I need one of those because it's too much. Also my internet just drops and then, it's great. But however, from now on, nobody else might ever be appointed teacher except for me. So we'll see. But I do appreciate you all for bearing with me during all of that time. But yeah, now we've got these nice extenders.
Your internet is perfect now. It's awesome.
Yeah, I mean, that's good to know because I also just thought it was in my head. And yesterday, we hadn't connected them until like lunchtime yesterday. And I had all my calls in the morning and then I didn't have calls in the afternoon. And so I was like, I don't know, my internet was so bad. Like, I don't know. And, my husband he was like, no, I think it's so much better. And I'm like, he was saying this like before I even plugged it in. And I was like, I'm like, so it's all just in your head, it's not true. And I'm like, I just plugged it in. There's no way, like I'm still connecting it. So the thing is for Joseph, for all you tech savvy, I did have to download because we got Google. I did have to download which I didn't know, there's a Google Home app and it connects there, which is really, cause then I can see if the router and the Wi-Fi extenders are working. And you can like literally connect them from your phone, which is pretty cool. And that's how I knew, and I hadn't even done that. And he was like, the internet is so much better. I'm like, I didn't even connect it.
And then it drops out.
And then I'm like, you just lost a call. So spoke too soon. But I don't know what QOTD is, but
questions a day.
Oh my gosh. I completely forgot. Okay. Here's maybe a thinker, but, and I don't think I asked this. Have I asked who like a role model for you is yet? Or you already did? Oh, I'm not going to ask who did you vote for. That's weird. I'm not as concerned with who you voted for. That's fine. Did you vote? You could answer, but yeah, I would say, I think if I didn't ask like, who's a role model to you, it could be someone like a family member, a friend, a famous person, like whatever. I think if I haven't asked that was my question for the day. My list got disorganized and I couldn't remember if I've asked it.
Recording stopped.
So I need to write this down if I haven't. But if I already asked it and you answered, that's fine. And I guess I should be giving my answer. I mean, I think, yeah, I would probably say my dad, even though my mom, well, I will say my mom today, I got to give her some props. She was a champ and she, in their hometown, she worked the polls. And she was there at like 4:45 this morning. And then they like feed her breakfast, lunch, and dinner, but she is still there now.